Alright, welcome back to Dr. Whee's math tutorial class. Today we'll be talking about how to factorize composite numbers. Now before I do that, let's define what a prime number and composite number are. Okay, so let's look at prime number first. What is a prime number? Well, a prime number is really a natural number that has exactly two factors, okay? Itself and 1. Now first of all, you probably wonder, what is a natural number? Well, a natural number is a whole number other than 0. So like, for example, 1, 2, 3, 4, 5, and so on and so on. Okay, so that is a natural number here. A set of numbers, a whole number other than 0. 1, 2, 3, 4, 5, and so on. Okay, so that's a natural number. So a prime number is a natural number that has exactly two factors, itself and 1. Now think of this number here, 11. 11 is a prime number because there is no other factor other than itself and 1 that can divide into it. Okay. On the other hand, when you look at 68, 68 is not a prime number because other than 68 and 1, other number can also divide into it. Okay. So that's what composite number is. Okay. So let's define that. So basically, a composite number is a natural number where prime numbers or factors, okay, I have to put S here, that can divide into it, other than, okay, itself and 1. Now think about this. 68, for example, can be broken down to 34 and 2. See, 2 times 34 is 68. So 2 can go into 68 34 times, or 34 can go to 68 2 times. And you can even break that down further because 34 can be broken down to 17 and 2. So you have 17 can go into 34 2 times, and 2 can go into 34 17 times. Now if you look at this tree diagram here, okay, I have at the end of each node here 2, 2, 17. These are the prime factors for 68. Okay, so this is a composite number because 68, okay, it's a composite number because other than 68 and 1 itself, if we don't count that, other number can also divide into it. Other prime factors can divide into 68, 2, and 17, okay? And 4, you want us 2 times 2 is 4. 4 can go into 68. 34 can go into 68 as well. But if you look at the prime factor, if you break it down, it's 2, 2, and 17. Okay? So there's many numbers that can get into 68. Do some question. Okay, we have 39, 17, and 74. Let's determine whether this is a composite number or a prime numbers. Okay, if it's a composite number, what are the prime factors that it's made out of? Okay, so let's look at 39 here. 39 is not a prime number, rather it's a composite number because notice here 3 can divide into 39 as well as 13. So 3 and 13 is the prime factors because 3 can divide into 39 as well as 13. So we have 2 prime factors of 39. What about 17? Well, 17, other than 17 and 1 itself, it cannot divide by other numbers. So this is a prime number. Okay, it's prime number. What about 74? Well, 74, notice, is an even number, right? So how do you know? If you look at the last digit, 2, 4, 6, 8, and if it's a 2-digit or more, the last digit is 0, it's even number, and that means that you can divide it by 2. If you can divide it by 2, it's a composite number. Okay, so 2 can go into 74 how many times? 37. Okay, so we have 2 prime factors that can go into 74. The question, of course, is how do we know 37 is a prime number? Well, let's list, a few prime numbers up to close to 50. Okay, for now. Okay, just 2, starting with the smallest, 3 to the biggest, right? 2, 3, 5, 7, 11. Sorry, 13. 17, 19, 23, 29, 31, 37, 41, 43, and 47 for now. Okay, in fact, there's a huge amount of prime numbers, and my guess is probably close to infinite. Okay, because it's an infinite number. Again, I can't prove that to you, but all I know is that there's a lot of prime numbers. So have a look at this set of prime numbers. Okay, we have these sets of prime numbers, and you'll notice that 37 is one of the prime numbers, and therefore that's 37 as well. Now there's a trick here where you can determine before looking through the series or memorize a series of prime numbers to determine that it's a prime number. The trick is this: you look for a biggest prime divisor squared. Okay, so prime divisor squared. If that number divisor squared is greater than the number we're looking for, okay, we would stop further from finding prime number that can get into that, which means that that is the biggest prime number. For example, think of 7 with the biggest divisor squared gives you 49. That number, the divisor squared, is 49. It's greater than 37. You stop. You don't go find other prime number to determine whether it's a prime number. That is the prime number. Okay. So, for example, you can keep going and say 11. Can 11 go to 37? No. 13, no. 17, no. 19, no. 27, 23, no. 29, 31, so on, right? And then oh wait, it's 37. 37 is a prime number. So the trick here is to square the largest divisor. It will not get into that number, obviously, right? You cannot divide into that. But you want to square the biggest divisor. Okay, so what happened here is 7 squared is 49. If it's greater than the number we're looking for, right, look into, then that means that 37 is the prime number, and we don't need to go further. We don't need to keep searching for the prime number, the largest divisor that can get into 37, because 37 is the biggest. It is the prime number, right? Okay, let's do another 3 set of questions and a bonus. So look at this number here, 232, and you notice that this is a composite number because it's an even number. We can divide 2 into it. Okay, so 2 can go into 232 116 times. In fact, we can even use a 4. Okay, but just to keep it simple here, I'll just use 2 for now. And then notice 116. That's an even number. We can divide by 2 as well, and that gives you 58. And 58 is also an even number. We can divide it by 2, and that gives you 29. So the question is 29 a prime factors? Okay, so far we have 2 times 2 times 2. They're all prime numbers or prime factors, and we're assuming maybe 29 is. Now, if you memorize all the prime numbers up to maybe 53, then you'll notice that 29 is one of those prime numbers. However, remember the trick that I showed you just the previous question. Look for the prime divisor that could divide into it, right, which will not. Okay, the biggest one, and you square it. So which one is that? That's a 5, right? 5 is a prime number. Square it, 25. So, and then a 7, square it, Okay, and it's 49. Notice that we'll have to stop after the 7 prime number. 7 cannot go into 29, but when you square it's 49, it's greater than 29, so we'll stop here. So we assume now that 29 is the prime factor. Okay, well, let's look at number 5, 207. Now this one doesn't look like there's anything that can divide into it, so you may think that it's a prime numbers, but if you look at the series of prime numbers starting with, like, say 3, cannot be 2 because it's not an even number, right? So a 3, believe it or not, 3 can get into 207. Okay, so for example 3 go into 20 6 times. Okay, 6 times 3 is 18. So 20 minus 18 is 2. Bring down the 7 here. So 3 go into 27 how many times? 9 times. Okay, so we notice that 3 times 69 will give you 207. Okay, so 3 and 69 it's a prime. Well, 3 is definitely a prime number or factor for 207, but 69 can be divided by 3 as well, so 3 can go into 69 to 23 times. So we have 3 prime factors. 3 times 3 times 23. Again, is 23 a prime factors? If you remember the series of prime number, you will say yeah, of course. However, if you don't recall whether it is, think of the prime number divisor. Okay, square it. Okay, so 5 is the biggest divisor squared, give you 25. It's greater than the number we're looking at, so we'll stop here. We don't have to go further to determine whether this is a prime number or not. So it is a prime number because 5 cannot get into it, and you can try 7, it won't go into it either, and so on. But if you look at the biggest divisor squared, and if it's the number squared is greater than the number we're looking at, and pretty much we can say that this is the prime factor. Okay, we have to look further. What about 177? Well, 177 here. Okay, we have a 3, I think, can also go into that as well. Let's see, 3 go into 177, so 3 go into 17 5 times. Okay, and so 17 minus 15 gives you 2, and 3 go into 27 9 times. 9 times 3 is 27, right? Okay, so it's going to be 3 and 59. The question, of course, is 59 is it a prime number? Well, it looked like 3 can get into that, but if you think about it, if 3 divided into 59, it's not going to work out. So how do we know what about other prime numbers? Well, okay, so think about the biggest divisor and square it. So 7 squared will give you 49. And 8's not a prime number, sorry. 11 squared is 121. Okay, so notice that it's the number 59 is greater than 49 but less than 121. So we're going to stop at this 11 prime divisor here. Okay, so we don't need to go further. We need to find other prime divisors divided into that to get whether this is a prime number or not. It is now determined to be a prime number. Okay, so the prime number for 177 is 3 and 59. Okay. Alright, let's do a bonus. Okay, here's a bonus question here. 627. Well, I think 3 can get into 627. How many times? Okay, so 3 can go to 6 twice, and 27 9. Okay, so 209. So 209 times 3 will give you 627. But is 209 a prime number, or is it a composite number? Well, it looked like 3 can get into it, but if you try to divide 3 into 209, you won't get a whole number. So it's definitely not 3 cannot get into 209. What about other prime numbers? Well, remember we have a 2, a 3, a 5, a 7, and 11, right? Definitely not 2, and we just said that 3 is not. 5 definitely not. 7, let's see, 7 go into 20 twice, and then you have, see, let's do that. Okay, so 7 cannot get into 69, so cannot be 7. What about 11? Okay, 11 go into 20 once. Okay, 1 times 11 is 11, so 20 minus 11 is 9. Bring down the 9. So 99. 11 go into 99 9 times. Oh, yeah, that works out. So this 209 is 11 and 19. Okay, so the prime factors for 627 is 3, 11, and 19. Interesting. Okay, again, I would try to memorize the series of prime numbers up to 47, I guess, or even up to 53, and then save you some time, right, to whether determine is a prime factors or prime numbers or not. I can get into the number you're looking at. Other than that, yeah, that's how you do factorization of any composite numbers.